In this video, we will be finishing and reviewing the linear regression, but also showing you about different technologies and different ways that you can do regression without using your graphing calculator. The wording needs to have special attention paid to it during this problem. So here we go. In recent years, physicians have used the diving reflex to reduce abnormally rapid heartbeats in humans by briefly submerging the patient's face in cold water. The reflex, triggered by cold water temperatures, is an involuntary neural response that shuts off circulation to the skin, muscles, and internal organs to divert extra oxygen-carrying blood to the heart, lungs, and brain. Okay, that really doesn't help us much, but it tells us what we're going to be studying about. A research physician conducted an experiment to investigate the effects of various cold temperatures on the pulse rate of small children. So the data for 7 6-year-old children are shown below in the table. Now, when you start entering these data values into your calculator, don't enter this first list because that's just an identification number of what child we're dealing with. So we basically are going to be entering our X value, which will be the water temperature in degrees Fahrenheit. There's our units and our variable. And then we're going to be looking at the decrease in pulse rate. In other words, when you submerge a 6-year-old in 68-degree water, we will expect a 2 beat per minute decrease in their pulse. Okay, so notice what I did. I looked at my first data point and I interpreted it so I could get a little bit of a feeling for what this problem was about. So let's review the steps on our calculator. First, we need to enter these 2 columns into our calculator, into the lists, which I'm about to do right now. We go to our stat screen, we hit edit, and there are the numbers all typed in. We hit stat, we go over to edit, down to our 4th choice, linear regression AX plus B, and we state which 2 lists we're using, and then we store our regression equation into the Y variable of our choice. I use Y1, and I hit the variables button. I move to the right to white variables, and then I choose function and Y1, and that will overwrite what's already in my Y1 with this new regression line. And when I hit calculate, out comes the values that we need right here. So going back over to our other screen, that's where I've already got these values sitting here that came off of our calculator. And when we write this regression equation, make sure again that you write this as Y hat. This is a sample regression line based upon sample data values. Now, part B asks us to graph the data and the regression equation on the same graph. Okay, well, I've already got that done digitally. Let's go review how we do this on our calculator. So going to our calculator, we already have just found these key values. We're going to hit second stat plot. Odds are everything's exactly as you need them, but for me, I realize, uh-oh, I never changed my second list to list 2. I left residuals there from the second problem we did in the last video. So now I've got the right values here, and I'm going to hit zoom 9, which is zoom stat, and out comes the graph that I showed you a moment ago. Now let's go back to our other screen here and answer some questions. Part C, describe the apparent relationship between the temperature and the pulse rate. Okay, this is asking us to describe what we're seeing. We see an indirect relationship because the line is going down, which means one variable is increasing while the other is decreasing. So I'm going to word this as the temperature increases, the decrease in pulse rate decreases. I know that's really Bad English. I probably have some extra words in here that I probably don't need. The decrease in pulse rate. Okay, I think this was a choice here, and I meant to cross off that part right here. Notice how we have a decrease in the pulse rate decreasing because the variable is a decrease in the pulse rate. So it's kind of weird having those two decreases there. So in this case, it would actually be okay to say the pulse rate increases. Okay, it's kind of a weird way of wording that. You might need to pause that in the video and think about that for a little bit. For part D, what does the slope? Okay, this is the one that uses this slope wording, which I have our boilerplate language sitting here for. And again, it's going to be a little bit awkward of a wording. For every one X unit. Well, my X unit was degrees Fahrenheit. We saw that at the top of our chart there. Increase. We always talk about an increase here in water temperature because that was our variable there. When we are talking about rise and run, we're always running to the right. So it'll always be an increase for the X variable. And then we're going to have the decrease here because our slope is negative. We had a negative 0.8 slope. So there'll be a decrease in pulse rate. That's what the variable is. Decreases by about 0.814 beats per minute. So that again, you might not want that decrease in the pulse rate. You might want to change that to an increase in the pulse rate. And that's where, I can't really put a formula to the English language in terms of how we write this out. You just need to kind of wrestle with those words a little bit so that it makes sense in your own brain. I think most of you would change the decrease and the decrease into an increase instead. Part E, identify any outliers. Well, looking at this graph, there's no vertical separation, and we don't have any points far off to the left or right. So again, none of either of those are present in this problem. When we move on to part F, it's asking us to make a prediction for the decrease when the water temperature is 60 degrees. So that's asking us either to enter 60 into the equation manually, okay? And I've interpreted this here, 9.229 is our decrease, so that would be a 9.2293 beats per minute decrease in the pulse rate would be my interpretation. Now you can either take 60 and substitute it into the equation, or you can go to the calculator as I showed you in the last video. Let me illustrate it here for you right now. Here's our screen. We're going to hit second calc. We're going to hit the first choice here for a value, and we're going to type in 60 as our X value. And out comes that Y value down at the bottom of the screen, which corresponds to 60 Fahrenheit water. Okay, so that's where I copied that value out of for that other screen. Heading back now, the predictor and response variables, that's just the X and the Y variable. The X is the water temperature, and the Y variable is the decrease in the pulse rate. R squared and R should be rather straightforward because they came straight out of the calculator when you did this linear regression. And J and K both need to be put into words. Now, don't always think R squared will always come first. You need to be careful of the order of these, and recall that R squared talks about how useful the equation is, whereas the linear coefficient R talks about the linear relationship between the variables. So those are the key words to watch out for so that you don't get those two reversed with respect to each other. Now, the interpretation itself, our R squared value is close to 1. So I'm going to say, since R squared is close to 1, the regression equation is very useful for predicting the decrease in the pulse rate. And then R happens to be negative here. So we're going to say, since R is close to -1, there's a strong negative linear relationship between the water temperature and the decrease in pulse rate. So, this was just a weird problem because the y variable mentioned a decrease. Maybe we should have used the word drop instead. But the English language is just a little bit weird, and we've got to be able to deal with it. Okay, the next thing I want to move on to is to talk about different technologies. You are getting used to doing things on our graphing calculator, and if you were able to read this problem, you know how I can go and type it in and get this output screen here, which is our regression equation. You know how we can graph the data itself, and we've shown you how you can find a residual plot. Well, that's using our graphing calculator. There are a lot of different technologies out there, one of which is Minitab, another which is SAS, and notice both of them will give us a graph of the regression data. Both of them will give them a graph of the residual plots. You just have to learn how to read them. In Minitab, they physically tell you, here is your regression equation. Whereas in SAS, they have you read off the y-intercept and the slope there. R squared, you have to know where to look for it. There it is on one output and R squared on another output. Now, when you leave this class, this is likely to be a topic that you are going to run into with another teacher, and they won't necessarily use the TI graphing calculator. So if that's the case, you then need to learn how to use that technology. And there's a small learning curve. What you need to be able to do first is you need to be able to first look at your calculator and determine, how do I enter my data values in? Okay, that's key number one. And then it's just a matter of where are the different menus that allow me to do the different things I need to do. Where do I find regression? And then once I find regression and it gives me an output, how do I read the output? Okay, the output will be the same, but it'll just be in a different location. So what I'm trying to do is help you get ready for that. Now, what I'd like to share with you next is how you can do this regression using Microsoft Excel. And you will be doing a problem like this for me as part of an activity we're going to do as part of a project, actually. And I've made up some data sets here, and I'm going to use this first one here where I have data dealing with a distance to a firehouse in miles and the response time. Now, I made these values up, and I basically thought of, 2 minutes for every mile. So I roughly doubled these numbers, and then I just kind of made them a little higher and lower just to kind of vary the data out a little bit. So that's how I made up this data right here. So it's in an Excel spreadsheet, and I'm going to go up to the top where it says Insert. And I'm going to have a bunch of different choices here. And look at right there, you can barely tell it, but I have a choice of different types of regression pictures. And I think that first one is the one I want. So I'm going to click on that, and it actually generates a regression line for me, which is kind of nice. And I can click on the top part and modify the title. And if I click on some of these side buttons here, it can allow me to enter axis titles. Notice I have a left axis here where I could enter in the response time here and miles from fire station down at the bottom. It also gives me a choice to enter a legend or a trend line. Look at that. My regression line just showed up in the middle of that data. Now I can click on this arrow and say, hey, I want linear regression or exponential regression, etc. I'm going to stick with linear regression there. And I'm going to now move on to some of the other options it may give me. So let's go over to this next button. That one just changed the look a little bit for me. I don't know if those are interest. I'm going to click on the filter, and I'm looking for something. I don't do this very often, but that's not what I wanted. Okay, let's find it here, folks. There's error bars. I'm not too interested in error bars, but let's go to more options and see what I get. Okay, well, that was not what I wanted to get. And you can basically just play around with these things. Let's go back to trend line here. Go down to more options. And oh, off at the far right, look at what we have at the bottom. Display equation on the chart. And I'm also going to say display the R squared value on the chart. Ah, looky there. Now we have those values that we need. I just probably don't like these. Looks like ciders for a bomber there. I don't know that I want those. So I'm going to just change those error bars and take those error bars away. And that's a pretty decent graph. It gives us our R square value. And I just wanted to show you how you could use technology other than our graphing calculators. And you're going to be asked to do this as part of your project. So I will leave you with that. Experiment, play around, because once you've played around with this once, you have a skill that you can continue to use once this class is over.